Hi everyone. In this video, we're going to look at how we can identify different types of equations so that we can then use appropriate methods for solving those equations. So first off, we have been working a lot with expressions in this class. And remember that an expression is a combination of operations, variables, which are unknowns, and numbers. But when we're working with an equation, it's when we have two expressions that are set equal to each other, that they're equivalent. And so in other words, you can say that an equation is a mathematical sentence where we have two equal expressions. And when we're solving these statements, we are looking for specifically the value of our unknown, the value of our variable, which is most likely going to be x. And to do so, we're going to use the rules and properties that we have used in evaluating our expressions. So remember some of those rules, which we'll go over in depth with examples in a later video, are the distribution property, our rules of exponents, our order of operations, and so on. So when we are identifying these different equations, we're looking at four in particular. And those are going to be our polynomial equations, equations with radicals, equations with rational exponents, and equations that are quadratic in form. So the first one that we're going to look at is our polynomial equations. So here I have an example, 3x cubed plus 2x squared equals 12x plus 8. So how I can tell that this equation is a polynomial equation is if I look on both sides of my equal sign, so this 3x cubed plus 2x squared and this 12x plus 8, both of these are polynomials. Now, another important thing with our polynomial equations is being able to find the degree of them. And so the degree is equal to the highest power of any term in the equation. So if I'm looking at this left-hand side polynomial, the highest exponent for x, well, we have 3 and we have 2. So the highest of those is going to be 3. So this polynomial on the left is degree 3. On the right, we only have one term with x in it, and that's 12x. I know it's unwritten, but remember that if there isn't an exponent with our x, then it's 1. So the highest power here is going to be 1, so that's the degree of that polynomial on the right. Remember that there are special classifications for certain degree polynomials. So if we have a degree 1 polynomial equation, it's linear. A degree 2 polynomial equation is quadratic, and degree 3 polynomial is cubic, and so on. Now, if we are looking for radical equations, this is when we have an equation where our variable is under a root. So here you notice that we have 2x under our square root. And so therefore we can say this equation, which is the square root of the quantity 2x plus 15 minus 6 equals x, is a radical equation. Now you'll notice that we also have an x that is not under our square root. That does not matter. As long as we have one of our variables under the square root, it is a radical equation. Another thing to note here is that radical and root are the same thing. So in this case, our radical is the square root. And you can also have different roots. So we can have a third root, the fifth root, and so on and so forth. And we'll see other examples, like I said, in videos in the future. Our third type of equation are equations with rational exponents. So here we have the equation 8x to the 5/3 power minus 24 equals 0. Now, rational exponents, that is the same thing. We could replace this word with fractional. So if we have an exponent that is a fraction, we know that we're going to be dealing with equations of this nature. And so in this case, you can see this x is raised to the fraction 5/3. And another thing to note is that expressions with rational exponents can actually be represented with radicals. So we can use very similar techniques that we do for radical equations. And again, this is something that we'll go into more detail in with upcoming videos. The very last type of equation we're looking at is equations that are quadratic in form. Now, a quadratic that we, like I had mentioned with our polynomial equations, is when we have a degree 2. So let's write that down. So quadratic means that we have a degree 2 polynomial. Now, if I told you that this equation here, x to the 2/3 power plus 6x to the 1/3 power plus 9 equals 0 is quadratic in form, you might think I'm crazy because there isn't an x raised to the 2nd power. But we're not calling this a quadratic equation. We're saying that it's quadratic in form. So there's something that we have to do to make it look like a quadratic equation. And so in this case, I have an expression that can be written as something squared. So if I look at this first term here, I can rewrite this as x to the 1/3 power squared. And the reason I can write it that way is because of our exponent rule. So if you'll recall, when I have a power raised to a power, I am multiplying those powers. So I would have x to the 1/3 times 2 power, which that is going to be equal to, remember, multiplying fractions, we multiply straight across. So 1 times 2, we get 2. And then 3 is our denominator. So I'm allowed to write that x to the 2/3 term as x to the 1/3 squared. And so therefore, if I were to call that x to the 1/3 something, we can call it a variable u, then that means that I can rewrite this equation as that u squared. And then you'll notice that this middle term also has an x to the 1/3 power. So now I can rewrite that as, instead of 6 times x to the 1/3 power, I have 6 times u plus 9 equals 0. So now this equation here, that is a quadratic equation. We had to use some sort of substitution to make it become a quadratic polynomial. One thing to note is that you can have one equation. So like, for example, if we have a equation with rational exponents, it is very possible that you can just rewrite it as a radical equation and then use that technique to solve that equation. Or you could have an equation that looks like it's rational in form, but it could actually be an equation that is quadratic in form. So some of these techniques are going to be interchangeable depending on how you choose to rewrite or keep your equation how it's given. So that is one thing to keep in mind. I hope you find this video helpful in identifying our different types of equations, and in the videos coming up, we will actually learn how to solve these types of equations.